Hi, everybody. It's Professor G back again. Now we just need to finish up a little bit on determinants and matrices by introducing how you do an n by n matrix. Really, we won't do much bigger than a 4 by 4 or 5 by 5 in this class, but still, we need to know how to do them. So let's go to our dot count. Okay, so we want to talk about the determinant of an n by n matrix. So now last time we looked at a 3 by 3 matrix and I introduced this notation. Let me point out, you can only talk about determinants for square matrices. So it has to be, 2 by 2, 3 by 3, n by n, nothing m by n. It can't have different number of rows and columns. So we used this notation last time with the subscripts. The first subscript tells you which row, the second subscript tells you which column. Now, I'm not going to derive the formula. I'm just going to tell you how the formula goes. So the determinant of a matrix, you can pick, now the way I've written it, you pick any row, the ith row, and now you sum as you go across the column. So that means if we pick the second row, we go across the second row every time. The I stays the same, but the J changes. So we go down the row, okay? So you take -1 to the I plus J. So you add the number of the row in the column. And then you take, what does this mean? Aij bar is the matrix you get when you delete the ith row and the jth column from your original matrix A. Okay, so that's how you get Aij bar. Delete the ith row and the jth column, and then we've multiplied by the Aij factor in front of it, the entry in the ij place in the matrix. And the straight lines, remember, mean take the determinant. Straight lines here means it's the determinant. Okay, not just the matrix. Okay, so that's the way you define the determinant of the matrix. Now, its equivalent, we could just as well say the determinant of A is equal to the sum as I goes from 1 to n of -1 to the I plus j, Aij, delete the row in the column containing I and j entry, containing the ijth entry, take the determinant of the remaining matrix and do it. So what's the difference between this formula and this formula? In the first formula, let me grab a different color pen. In the first formula, the sum is you're going across a row. In this formula, you're going down a column as you sum. So you pick, in this formula is the equivalent one where you pick a column and you go down the column, okay? All right, so either one's equivalent. They both work. It turns out they're both the same, give you the same values, and that's how you do the determinant of an n by n matrix. Now, I'm not going to do a huge one, but let's do an easy example because these get quite long. They can take a while if you have all non-zero entries, even if it's a 4 by 4 matrix. So suppose we take the matrix A to be the matrix 1, 0, 1, 0, 0, 0, 1, 1, 1, -1, 1, 0, and I don't know, 1, 2, -1, 1. Okay, I'm just made up a matrix. I have no idea what the determinant will turn out to be. Okay, but if I had to pick a row or column to go with, I would either go across the second row or down the second column or down the fourth column. Why? Because I got 2 zeros either way I do that. So let's just, for the heck of it, go across the second row. So I'm going to use the second row. Now I have to remember that I have to alternate the signs. That's that -1 to the I plus j term there. So when I say I'm going to use the second row, let me show you what the formula I wrote down before. That means I'm letting I be 2. So the formula would say take the sum from j equals 1 to 4 of minus 1 to the 2 plus j, because I'm using the second row, so I is 2, a 2j, then the determinant of the matrix I get when I take a 2j, delete the 2j row and column from the matrix A, and then take the determinant of the resulting matrix. So that's the formula I wrote down before. Let's apply it. So I'm going across the second row. So I have minus 1 to the 2 plus 1. So this would be a minus sign first, but my first entry is 0. Okay, so I don't need anything else. Once I have a 0 there, I'm good. Okay, so now the next one is going to be, again, 0, because the entry there is 0. Okay, so I'm good on that. Now I get minus 1. This is a 2, 3 entry. So that's minus 1 to the 2 plus 3. So that's going to be a minus 1. Then I have to take the number 1 because that's the entry. And now I delete the row in the column containing 1. So that now I have to think carefully. I'm deleting this row, this column, and the second row. So what do I get? I get 1, 0, 0. And then in this one, deleting the row in the column, the second one's gone. So I get 1, minus 1, 0. And in the third one, I get 1, 2, 1. Okay. And then I have to say plus. I'm not done. That was my third entry. And then I get minus 1 to the 2 plus 2 times 1. And now delete the row in the column containing 1 and take the determinant of the matrix that's left. So that will be 1, 0, 1. When I delete this row, just to make sure everybody gets what I'm doing, and this column, I get 1, 0, 1, 1 minus 1, 1, and 2, 1, 2 minus 1. Okay, so it's just messy now. So the first 2 is 0. I don't have to worry about that. This gives me a minus. Now I have to take the determinant of this 3 by 3. So what's the best way to do that one? Well, let's go just across that first row, because then I'll get minus, and now I'm taking the determinant of this guy. That will be 1 times the determinant of what I get when I delete the column containing 1. Okay, so I deleted the row in the column containing 1. That gave me minus 1, 0, 2, 1. And I have to take the determinant of that. And the minus sign was from here, and the 1 is this one. Okay. And now I don't have anything else to do because I'm going in this determinant of this 3 by 3 because I get a 0 here and a 0 here. So that's real convenient to go across that row. And now the next one I have to worry about is this guy. So this is minus 1 to the 4th, so that gives me a plus 1, another plus 1. And now I have to take the determinant of this 3 by 3 matrix. We only have 1, 0. So I'm still going to go across that first row, but I'm going to have 2 terms I'm going to have to deal with. So when I do this, I'll have 1 times, delete the row in the column containing the first 1. And now you'll get minus 1, 1, 2, minus 1. Then you get minus 0. Maybe you have to alternate signs when you do this. Minus 0 times, so we don't have to worry about that. And then you get plus 1 times, delete the row in the column containing 1. So that'll be 1 minus 1, 1, 2. Okay. All right, so it turns out, let's see, now when I do this, this is a minus sign. And now when I take the determinant here, I'll get minus 1, minus 0, so that's minus 1. Here I'll have 1 times, when I take the determinant here, I'll get a plus 1 and a minus 2. And then when I take the determinant here, I'll get a 2 minus a minus 1. So that gives me 1 and minus 1, that's 0, and 3 is 3. So the determinant of that big 4 by 4 matrix. And I think it's not hard for you to see that if you didn't have so many zeros, this could get to be a problem that would take quite a while. Okay, it's not a hard process. You just have to be a good bookkeeper. Okay, that's it for this lecture.